Hello and welcome to the next episode of Java in the Cloud. Today I've got a good friend of mine, Sascha, here with me. Hi Sascha, do you want to give a quick introduction?
Hey, Mark. Thank you very much for the invitation. Sure. My name is Sascha, and I'm a specialist solutions architect for containers. So this means helping customers on their journey to the cloud and all container-related things. And I used to work as like software developer and software architect. And I try always to have an excuse to play around with code. So this is why I still invest quite a lot of time into doing Java related stuff.
Fantastic. And me and you used to work together at AWS and we used to do all sorts of Java stuff together. So it'd be really interesting to see what you've come up with today. I've been following along on LinkedIn. But first off, let me just ask you, what is a technical book or technical resource that you found really useful in your career?
So basically two things. So when it comes to like the more professional life, it is Hibernate in Action by Christian Bauer and then Gavin King. So back in the day, as already mentioned, I used to work as a software developer, and we use Hibernate, and it can be quite complex, especially if you do a lot of this lazy loading stuff and so on, and performance optimization. So this book was super helpful to get everything up and running at a decent speed.
Yeah, I still find those some of like the most interesting conference talks that I listen to is people working on JPA mistakes or Hibernate improvements, and I got this exception, so I changed my linking to be lazy loading or eager loading, and then suddenly I've got a n+1 select problem. it's, it's so easy.
We ran into those issues as well. It was like, okay, now it works, but it's now super slow. What can we do? And for some of the queries, we just say, okay, we just use standard SQL, and that's it. So
Yeah,
hand optimized SQL. I mean, for 80% of all the things, Hibernate is just amazing. But for those 20% where you have like queries where you do a lot of, I don't know, data warehousing related stuff and reporting and so on. So it makes sense to have hand-tuned SQL
yeah, and
statements.
it's that next step of in your career, isn't it? It's understanding the framework enough to be able to get it to do what you want to do.
Exactly.
Awesome. Well, just one funny story before we get into starting. So Sasha and I used to work together at AWS, and internally we used to have questions and answers website. And I was pretty early in my career, and I guess Sasha had been at AWS for a while. And I was looking through all of the questions that people were asking about things like X-ray and Lambda and Java. And there was this question about, how do I make my Lambda function faster? I was like, oh, let's have a read of this. And then I was like, oh, this Sasha guy is talking about GraalVM native image. What even is GraalVM native image? What is he telling people to do? He's telling people to recompile their code into a binary and then run it? What on earth is this? And I remember distinctly saying, this is a terrible idea. No one would ever do this. And then I think for the next 2 years of my life, I really dug into GraalVM native image, and I spoke to so many people about it, and I built websites helping people to use it. So there you go. Always listen to what Sasha says.
Nah, not always. There are many times I'm wrong, and that's okay because we're learning every day is a school day. But I mean, this GraalVM is like a very interesting concept, but the thing is, it has, of course, its downsides and its impact, and as always, it's a trade off. You have this closed world scenario from a compiler perspective, like things like byte buddy won't work, so your APM tool will run into a challenge sooner or later, and then compile time things. But the performance is just incredible. But nowadays you also have Snapstart and so on, which also helps a lot.
Yeah, and I think for especially for containers, having a GraalVM native image which has such a reduced memory footprint really helps pack in more applications onto a single host. But probably another day. We could probably talk about GraalVM native image for another hour. But what I really wanted to talk to you about is the work that you've been using, the work that you've been doing to use large language models to analyze thread dumps and heap dumps for applications that might be acting incorrectly or having issues. So yeah, please tell me, give me an overview of what you've been up to.
So let's go back a couple of months. So I've spent quite some time doing Java related stuff with customers. So like customers raised some concerns about their performance or the performance of their applications running in containers. So in their data center, it worked like a charm, and then moved it into a container into AWS, and then they had performance related issues. And 80% of the time, it was a combination of, okay, I have a container and I have Spring Boot, and now it's super slow. So this is why we have spent some time working on content, how you can speed this up. So as you've already mentioned, GraalVM is one of those things. The other thing is, for instance, AppCDS or coordinated restore at checkpoints and all the other optimization techniques. And so I had discussions with a lot of huge enterprise customers, especially with their development teams, and also one particular customer speaking with their platform team, and they mentioned that they have like thousands of Java applications running, and they have no idea what those applications are actually doing, because the developers are just throwing it over the fence, and they have to run it somehow. And then sometimes they have problems with like applications not behaving as expected. And so from time to time, they have to do like a heap dump or thread dump analysis and so on. And one of the challenge they raise is we actually don't know when to pull a thread dump, because usually when we see that the application has a problem, it's too late. So they immediately have to pull a thread dump based on metrics. So so that's when I started thinking about how could you actually implement something like this? And the easiest thing would be to say, okay, based on certain metrics that you have like an automated trigger to pull a thread dump. That's where I basically started. So I had this idea doing it based on CloudWatch metrics initially, and then maybe having a Lambda function or a sidecar that is doing the or that is creating the thread dump, and then you have it in your file system S3 bucket, you name it, and then you can analyze it using Visual VM or whatever. So the tools that you basically prefer. And then I started implementing it, and I thought, okay, I don't like the sidecar approach because it has an impact on your cluster, because this means you have to run additional software in your cluster, you have to maintain it, and it's also it's also eating up resources, right? You add additional sidecars, which means you reduce the utilization of your cluster because you have additional workloads that you have to run. And for Kubernetes, it's super simple to just say, hey, admission controller or webhook, run yet another sidecar, and then you have your application, and then 3 or 4 sidecars run. So
yeah, and it really isn't the sort of thing that you want to have running all of the time. The whole premise of the problem and the solution is that you only want to use the solution at a specific time, and that time will be defined by some sort of trigger, and that can be some sort of metric.
Exactly. And especially with Kubernetes, it is pretty straightforward, because what you actually have to do is you have your Kubernetes API endpoint, and then you say kubectl exec, and then something, something, something. in your pod and in your container, and that's basically it. So you don't need access to the EC2 instances, which is also great. And obviously, this is also works in other environments. So let's say you use ECS or something like this. And so the current implementation looks a little bit different because I wanted to have like a scalable approach that is also using additional meta information that I create in the application. So the downside of this approach is I need to create additional metadata so I can say, okay, I have problem in this application. It's running in this namespace. The task is called like this, or the pod is called like this, and so on and so on. So this means
okay. So when not only because when you have an anomalous metric, you need to then go from that metric to be able to work out which part of the application you need to analyze. Okay, because these
exactly.
clusters could have many different pod services, and you need to know specifically which one to execute the thread dump on.
That's the tricky part. You need to know what exactly is causing the problem. And if let's say you have your standard Kubernetes deployment where you have like a replica set and multiple pods, and in your pods you can have multiple containers. So you need to know which pod and which container. So it can become a little bit tricky. And I've noticed that after scaling up my application, then, okay, which pod should I choose now? Then I came up with a solution to create this additional meta information. And this is basically in the application. And it's using standard mechanisms like the micrometer Prometheus integration. That's basically using it. And then in the registry, I just say, okay, use a specific set of tags like cluster name, which cluster type am I running in? Like, is this ECS or is this EKS? The container name. And then for ECS, I also need the IP address of the Fargate instance I'm running in, because I need access in ECS directly to the EC2 instance. I can't use, for instance, ECS exec. It's not working in the context of Lambda. So there are different implementations based on where you're actually running in.
Brilliant. Do you want to bring up the architecture diagram, and then we can have a little look about how it all works together?
Sure. Just a second. Okay, here we go.
So the part that you were talking about just then is that the parts on the right-hand side, the Amazon EKS applications or ECS applications, have been altered to produce additional metadata, and that metadata will find its way into Prometheus.
Exactly. And that's pretty straightforward because it's just using Spring Boot functionalities to do that. So that's the easy part.
Yeah.
The tricky part starts when you want to scrape your Prometheus endpoints from your application and then start pushing it or start pulling it, depending how you want to get your metrics into Prometheus, because Prometheus and Grafana are running in an EKS cluster. So if you are running your applications in the same cluster, it's super easy. It's just scraping. But if you have your ECS application, this is maybe running in a different VPC or something like this, then it becomes a little bit more tricky. Then you need an internal load balancer and push the stuff into the into Prometheus.
But it's probably also a solution that people have probably solved. If you're running EKS or ECS,
Yes.
it's probably a well-trodden path that applications need to have a way of saving metrics. And then you're using Grafana webhooks. So Grafana hits a threshold for a specific metric. You've defined that as a problem, and then Grafana at that point sends a webhook to a Lambda function.
Exactly. That's the implementation. It's using the standard Grafana alerting rules and alerting mechanisms, and then I have my webhook as a contact point in Grafana defined, and then Grafana can access the webhook. Of course, I have some authentication implemented because it needs to be a public endpoint. So this means there is basic auth implemented, and I have the secret shared between Grafana and the Lambda function.
I see. Yeah, that makes sense. And then from there, the Lambda function has all of the information it needs because Prometheus has all the metadata about the application. That's delivered as part of the webhook. And now the Lambda function can call the Kubernetes API or the ECS API to then go execute, thread dumps or whatever action on each of these applications.
Exactly. That's how it's implemented. And it's using the metadata to do two different paths in the Lambda function, depending if it's EKS or if it's ECS. And then it's doing its thing. It's doing the kubectl exec thing, or it's calling the actuator endpoint to create a thread dump.
Fantastic. So then after it's made that API call, synchronously it's going to return all that data, and then you're using that data to then call Bedrock, so Amazon Bedrock, to then ask Claude, what could be the problem that has caused this to happen based on the data that you sent it.
Exactly. So the implementation, the initial implementation was like just getting the thread dump in an S3 bucket. I could download it and then using QDeveloper CLI to analyze it, which was surprisingly good results. I was really impressed by that. And then in the LinkedIn commentaries, one person mentioned, "Hey, it would be great to have like a Bedrock integration." I thought like, okay, why not just add it? Should be pretty straightforward. And actually, it's not that complicated because the Bedrock API is super straightforward.
Yeah.
And I've tried a couple of different models, and Cloud 3.7 was really good. And I have, of course, a very specific prompt to tell Bedrock, hey, I want those specific results. Check, for instance, on blocking threads and what could be the reason. And the result is pretty impressive because what it also does is based on the information it has in the thread dump, it says, okay, it could be potentially this piece of code that I have recompiled or that I have decompiled, and you might take a closer look. Maybe this is a problem.
Okay, I didn't expect it to do that. That's impressive.
It is, yeah.
Okay. Wow. And I guess the really interesting thing about this use case is that a lot of LLM use cases that I see have, potentially quite high throughput, quite high usage of an LLM. So you do have to, really focus on the prompt and the context, but also the model that you're using. Do you need to pick a model that has a lower invocation cost or a lower token cost? But for this, basically the cost is going to be almost zero because you're not doing constant thread dumps. You're doing it when there's an issue. So there might be an issue once a week or once a month. So really, you can use the most powerful models. Also, latency isn't really an issue. So you can you can really go to town, think really deeply and come up with the best possible output.
Exactly. And if it takes like 2 or 3 seconds longer, it doesn't really matter. I mean, it's now a couple of seconds, and then you have a report that would usually take hours to produce.
So now you've got to automate it further and say, when there is a problem, do all the work and then Slack me the results, so I don't even have to know that something's happened. You gotta keep going now, Sascha. I wanna see this as a full full application.
That's an interesting idea, but then I think you need to have like an agentic approach to do all that. But this would be super cool. I agree.
Awesome. I think you said you had a demo prepared. Do you want
Yeah,
to show anything?
sure. Just 1 second.
See if the demo gods are with us.
So yeah, demo always a bit tricky. So let's start with Prometheus and Grafana. So what you see here is basically I have my application running, and at the moment it doesn't really do a lot. It's like 21 threads approximately, and I've used the metric JVM threads live threads. And I mean, you could pick whatever metric you like, right? So it doesn't really matter, but I picked this one because this was specifically mentioned in the customer case where they said, okay, sometimes we have applications that are just running wild and creating threads and threads and threads, and we don't know why. So, and the metadata I have spoken about, you basically see this here. It's basically the application name, and this is a specific additional tag that I have added, OpenTelemetry JMX Unicorn Store. The cluster is called Unicorn Store. The cluster type is EKS, and then I have like the IP addresses, which I don't really need in this particular case. I just need it for ECS. And then the container name is called Unicorn Store Spring. And also the namespace is important here. It's also called Unicorn Store Spring. I mean, this is for our demo application. There would be a little bit of more variety when it comes to names. And then I also have the instance ID here, and the pod name, and some additional information that is used. So, and then if I go into my analysis bucket here, I don't see a lot because there haven't been. Okay, fine. So, and then if I say, okay, I just want to create more threads, I have like an API endpoint here. What it basically does is it's just calling the application /threads start, and then I create 500 additional threads. And in a couple of seconds, you can basically see those threads going up here.
On the endpoint just to show behavior.
Exactly. It's just a dummy endpoint. It doesn't do a lot. It's just creating a lot of threads. That's basically it. Takes a couple of seconds before you can see it in the application, obviously because scraping and then Prometheus and then Grafana.
Magic of editing.
Yeah, exactly. So you can see this spike here. And if we go to alerting, we can see our alert rules. And also currently it's normal, but then it's switching to a different state because it detects, okay, we have this alert defined in this particular alert rule, and this is called high JVM threads in Lambda. And what it does is it basically calls this particular webhook URL if it's above a certain threshold of threads. In our case, it is 200 threads. And here we see, okay, it's panning. And then it's after panning, it's going into this firing state. And then what it does, it basically just does the thread dump or creates this thread dump. It also takes a minute because I had this 1 minute threshold because I don't want to just do it whenever there is like a peak of threads. It should run for
a sustained issue. And
exactly.
Just so, in case people aren't aware, you can use a feature of a Lambda function called function URLs to allow you to have a public endpoint for a Lambda function. So this is a very simple way to, do a use case like a webhook, which is perfect for this one. And there we go with firing.
Exactly, it's firing. And then after a couple of seconds, we can see.
So right now it's going to be calling the Lambda function. The Lambda function will be calling the EKS cluster. Your applications will be doing the work. It'll be sent back to Lambda. and then Lambda will analyze the data with Bedrock. So all of this is happening right now.
Exactly.
Got some results.
Not yet. It also takes a couple of seconds because first it has, of course, to call the EKS API. It does a little bit of handshake, token refresh, all that is necessary. And then it's using kubectl exec. This also takes a couple of seconds. And then you have finally your thread dump. So, okay, we now have a, let's call it subdirectory in our S3 buckets. I mean, S3 buckets don't have directories, but you have your keys. Okay, here we can see object has been created, and we can see, okay, this is the thread dump that has been pulled, and this is the analysis. And if we download it, so what we see here is the markdown output of it. I've instructed Bedrock, of course, to create a markdown document. So we see here we have 457 threads in wait state. In time waiting, we have 10 waiting threads, total threads 525, some key issues identified, a couple of optimization recommendations, particular thread pool implementation, task-based approach, reduce the thread count. And what is cool is it says, okay, it follows a specific pattern. And this is the class that is probably causing it, thread generator service, which is pretty obvious.
Yeah.
But this is the LLM is doing it based on the context and the information it has from the thread dump. So there is no additional information included. And that's it.
Wow, that is really fantastic, and I think this is what LLMs are really good at, aren't they? They're good at taking kind of obscure data, and we could probably do that work. It's just having an automated process to do the first summarization of it is just super useful, I think. And I think it is a really good use case for using LLMs. And there will undoubtedly be other issues where it isn't able to solve the problem because it's a unique problem or specific to a customer code base, and the LLM doesn't have hasn't seen evidence of prior issues. But I think there's probably a lot of cases where people are making similar mistakes, and the LLM probably can actually do a really good job of that first summarization.
Exactly. And I see it more as some kind of a blueprint or pattern which you can use to do, like, let's say, LLM instructed or supported analysis of problems that you have really independent of the actual implementation. I mean, this is now for thread dumps because this is a common thing that comes up, but you could think of basically everything that your architecture or your application produces. It's a very straightforward way of doing it. You have your metrics, you have a threshold, you have an action, you pull some data, and you put this data in addition with a prompt into an LLM, and then you get a result, and that's it. And with Bedrock, it's super easy because you have this endpoint, you call it, and that's it.
Yeah, and it's also very easy. If there was a particular new model that was released, tomorrow or next week that was particularly good at this sort of analysis, it would be very easy for you to swap it out. And again, because of the use case, money or per invocation cost isn't really important. So it'd be very easy for you using Bedrock just to swap out the model.
Exactly. I mean, it would be at the moment in the Lambda function, of course, the model is hard-coded, but what you could do is put it into parameter store or have an environment variable or something like this. So it could be dynamically configured.
Yeah. Super. And I'm pretty interested in trying this now. How do I try it?
So at the moment, it is included in a preview build of our Java on AWS Immersion Day. You probably know it. You've seen it a couple of times. we have this Java and AWS Immersion Day, which covers a couple of different things. So it is basically tailored for developers that have a Java problem, Java application somewhere running and now wants to put it into AWS or want to do some optimizations. And we're currently working on an additional lab for analysis of the workload. So this would be called JVM thread dump. So you have to wait for, I don't know, 1 or 2 additional weeks because we have to wrap everything up. We have to do pull requests and merge all this stuff into a GitHub repository. And what we're also working on is a couple of weeks ago, we have published a blog post about async profiler. You should be.
Oh, yeah.
Yeah. This is going to be a lab as well, because how we've built the blog post is that we have basically implemented an extension of the existing workshop / immersion day. So the code is already there. We just have to write it down.
So it's in preview at the moment, but hopefully it'll be released by the time this video is released onto YouTube, and we'll include a link in the show notes for how to access it.
Yes.
And is this code that supports this functionality going to be open source?
Yes, we have a GitHub repository. It's under AWS samples, so it's open source, so people can actually do pull requests or raise issues, ask for additional labs. So this would be one of the asks. So if you want to have additional labs, please let us know, because this is always super important. We can, of course, come up with stuff. We can come up with things that are influenced by customer feedback, but it would be also great from the Java community that we get some ideas for new labs.
Yeah, which is where this came from originally. This was from a customer having a performance issue when they brought an application to EKS, something to do with threads, and then this is the work that's been done on the back of it to help customers in the future.
Exactly.
Fantastic. Well, this has been really interesting. I was really blown away by the short snippets that I was seeing of your work on LinkedIn, but how it all comes together and how you've produced the metadata at the start of the application, feeding that into the metrics store, producing the alerts. I think it's a really slick solution, and also something that can be delivered as part of the platform, so that again, developers building these applications don't necessarily need to change much about their applications, and they have this new capability. Super
exactly.
Cool.
It's not too much, of course. You need to have this open telemetry integration. So at the moment, what I do is for EKS, I roll out the OpenTelemetry software, the OpenTelemetry collector in the cluster that is doing the scraping, and then then exposing an endpoint for Prometheus to be scraped. For ECS, it's a little bit different. So that's basically what people have to do, and a little bit of additional code to expose the necessary metrics, but that's it more or less.
And presumably how you've included those extra metrics will be in source code somewhere for the workshop or in a code sample somewhere, so we can link to those as well. So then if people are wanting to produce this solution themselves, they'll be able to follow similar work that you've spent a long time making.
Exactly. I mean, the actually the most complex part here was to bring everything together so that everything is working. So, I mean, the Lambda function is pretty straightforward. The OTel integration is not too complicated. Setting up Grafana and Prometheus is also pretty straightforward, but bringing it all together and getting it up and running also in an automated fashion, this is quite complicated, because for the Prometheus and Grafana setup, I've implemented a bash script, and this is now over 700 lines to get everything up and running the way I needed for this particular project.
Yeah, very cool. Thank you so much for showing us this and doing all the work and sharing it so openly. I think it's super cool. If you've enjoyed this content, please give us a thumbs up on LinkedIn. And if you've got any comments or feedback for Sascha or myself, please leave them below. And if you've liked this content or want to hear about future content that we're going to produce, then please hit that subscribe button as well. Thank you very much.
Thank you for the invite.